Hello guys, welcome back to my channel. Um Today we're going to be looking at exact differential equation. So now let's just go straight to the point. Now we said an exact equation mx m, which is a function of x and y, dx plus n, which is also a function of x and y, dy equals to 0 is an exact equation if derivative of m with respect to y is equal to the derivative of n with respect to x. Then, given the equation fx, which is a function, given any function f, which is a function of x and y, differentiating that function, we have the derivative of x with respect to x dx plus derivative of f with respect to y dy, such that the f dx is equal to m which is a function of x and y, and the f dy which is a function of n which is a function of x and y. So all this will make sense when we start solving a problem. So now let's take an example so you understand what I mean. Particular question, we want to take a very simple question so you can easily understand, then you can solve other tougher questions by yourself. So we're going to be looking at dy dx equals minus x squared plus y squared divided by 2xy. So how do we solve this? How do we know if we are going to use method of exact differential equation? First, we know that this is a homogeneous equation because the order of x, both x and y at the numerator is an order of 2. Then if you check the denominator to x is having a power of 1 here, y is also having a power of 1 here, so it is also an order of 2. Then to solve this, if you are asked to solve, if you are given, mostly when you are asked, when you know when to solve using exact, or when to solve an exact differential equation, the equation will be expressed in this form: mxy dx plus nxy dy equals 0. Now, for example, you are given this particular equation and you are asked to solve this exact differential equation. Now, the first thing you do is to express it. Like I said, when you are to solve an exact differential equation, it will be giving you, mostly the question will be giving you in this form. So if you are given the equation in this form, the only thing you do is to express it in this form. So how do you express it in this form? Given y dx equals minus x squared plus y squared over 2x. Now take this over to this other side. We have dy dx plus x squared plus y squared over 2xy equals 0. Now let us multiply both sides by 2xy. We have dy times 2xy plus dy dx, plus x squared equals 0. Is that you following now? Now multiply both sides again by 2xy multiply both sides by dx. Now there are other methods of you expressing this to this. This is just basically a step-by-step method. You can just say cross multiply from here. And that's all. So multiply both sides by dx. We have dy 2xy plus x squared plus y squared dx equals 0. So we see we have finally expressed this particular equation as this. Now how do we know if you have expressed this particular equation as this? Let's compare this. Now rewriting this, we have x squared plus y squared dx plus 2xy dy equals 0. Now comparing it with our general form of exact equation, we have m, the function which is a function of x and y dx plus n which is a function of x and y dy equals 0. So we see that my m is equal to x squared plus y squared and my n is equal to 2xy. So let me just rewrite it. My m is the function of x and y is equal to x squared plus y squared, and my n, which is a function of x and y, is equal to 2xy. Now, this is your first step. In case you are not giving it in this exact form, you try to express it in this form. Now, this is how we start to solve an exact differential equation. So basically, you should be given this kind of equation if you have to solve an exact differential equation. So now, the first thing you do before solving an exact differential equation is to test for exactness. The first step, test for exactness. Now, how do we know a differential equation is exact? Now, a differential equation will be exact if the m dy is equal to the n dx. Now, what does this mean? If the derivative of m with respect to x is equal to the derivative of n with respect to dx. Now, let's test this particular equation for exactness. We are given m to be x squared plus y squared, and we are given n to be 2xy. So let's test for exactness. So now, given m to be, m is giving us x squared plus y squared, and my n is giving us 2xy. So let's test for exactness. So the derivative of m with respect to y will give me what? Which is what? 2y, right? And the derivative of n with respect to x give me what? 2y. So we see that the derivative of m with respect to y and the derivative of x with respect to x are giving me the same value. Then I can finally say that this equation is exact. So my second step after testing for exactness is to assume a particular function, because basically solving differential equation is to get a particular function of my dependent variable and my independent variable, meaning that I'm not supposed to say any other derivative of any function in that particular equation. So basically I assume a function, an implicit function, which is f, which is a function of x and y, right? This is the function I'm working with, this is the function I'm to arrive at. Then if I choose to differentiate this particular implicit function, I have f prime is a function of x and y be equal to derivative of f with respect to x, right, dx, plus derivative of f with respect to y dy. We can remember our partial differentiation. So now, then this is the function I'm to obtain, right? This is the particular implicit function I'm trying to get. So now we compare this to our equation. For example, you know that the standard form of exact equation is what? M is a function of xy dx, right? Plus n, which is a function of xy dy, right? Is equal to 0. Now you can see from here that m is equal to df dx and n is equal to df dy. So basically this is all what we need. So now my m in this particular equation is what? X squared, right? And my n in this particular equation is what? 2xy. 2xy dy. Is that taken? So now your third step, after you have easily gotten the expression for your equation, then your third step is to take either any of this function, taking m and equating it with this, or taking n and equating it with this. So taking m and equating it with that, which is equal to, the x is equal to mxy, right, which is equal to x squared. Now remember, I'm trying to get my function, right? I'm trying to get my function. So let me integrate this particular equation to get my function. So we know that the f is equal to x squared plus y squared dx, right? And I integrate with respect to x. Integrating this, I have f, which is a function of xy. Remember, I'm looking for my function, right? That's the purpose of solving exact differential equation. I'm trying to get a function of y and x. So now integrating this particular function with respect to x, this is 3 x raised to power 3 over 3, right? And integrating this with respect to x, this is y squared x plus c will be a function of y. Why is c a function of y? Because we are integrating this particular function with respect to x. So integrating this particular implicit function with respect to x will make this constant you have to get to be a function of y. Now, we move on. Now, you know that if I differentiate this, remember we said what? N is equal to the f dy, right? And n is also equal to 2xy. Now, remember if I differentiate this f with respect to y, I should be able to have n. Is that taken? Now, let me recap. I compared the value of m with the f dx and got this particular function. Now, this is the function we are looking for, but it's not complete because we don't know the value of the constant, right? Now, if I choose to integrate this particular function, this function I have now, if I choose to integrate it with respect to y, and we know that n is a function of the f with respect to y, I should be able to compare it with this particular n function to get my constant. Now, what am I trying to say? Now, let me differentiate this with respect to y. The f dy give me, differentiating this, we have what? 3x squared over 3, right? Differentiating this with respect to y. Differentiating this with respect to y, this is 0, right? Which is a constant. Differentiating this with respect to y, x is a constant, right? And this is 0 plus differentiating this with respect to y, this is 2yx, right? Plus c, which is a function of y, c prime. Because I differentiated this with respect to y, which is 2yx, plus differentiating this with respect to y, this gives me c prime. Is that again? So this is the f dy is equal to 2xy plus c prime of y. Now, you see that this it differentiated this particular function to have this. Now, knowing that my n, we said, is equal to the f dy. Since we said my n, just like we said here, my df dy is equal to my n, which is a function of x and y, and which is a function of 2xy, right? We said this. So now, the new function we got, we differentiated it with respect to y to see if it will give us the exact value of n. Now, you see that we are having a constant here, so we can easily compare. So since this is equal to this and since this is equal to this, let's compare. So comparing it, we have, comparing this and this, we can see that there's a 0 figure here, right? Comparing the two values, this is the f dy equals 2xy plus c prime of y, and this is the f dy, which is equal to n with respect to x and y, is equal to this. So comparing the two equations, we see that my c prime of y is equal to what? 0, right? Then if I integrate both sides, integrate my c prime of y, my c, which is a function of y, will be equal to what? A constant. Is that taken? So now, since I've gotten my c, which is a function of y, because that's what I need to put here, then I can say x raised to my function, which I'm trying to get, x raised to power 3 over 3 plus y squared x, then replacing this my value of c, which is a function of y, to be equal to c. So plus c. Now remember, differentiating your exact equation be equal to a particular constant, let's call it a, right? So since we're having two constants here, we can take the other constant to the other side. This is x to the power 3 over 3 plus y squared x plus a minus c. Now these are both constants subtracting each other, which eventually give us a constant. So this is x to the power 3 over 3 plus x y squared is equals to, let's call it giant C. So this is a solution to my exact differential equation.